I mentioned at the start of class what I plan on doing a little bit later is we're actually going to conduct the hypothesis test in Excel for that Australia data set. The first step is we need to formulate our hypotheses. But with that Airbnb data set, I've already kind of honed in on the Waverley neighborhood within the Sydney, Australia area. And also, since it's a long trip to Australia, depending on where you're coming from, but from the States, it's a long trip. Most people probably would be interested in staying for a longer period of time, really focusing in on my Airbnb areas that had weekly prices. So a lot of the things that we've done so far, we were focused on the nightly price. But here I'm going to formulate my hypotheses about the weekly price. And I've done market research and I'm thinking like $200 a night for a week. So 200 times 7 would be $1,400. I'm going to state my null and alternative hypotheses around this hypothesized population weekly price of $1,400. So a good way to think about this when you're constructing your hypothesis statements is, what are we trying to disprove? So in this case, what I'm interested in is that it's less than $1,400. But if I see it as less than, then we know that our alternative hypothesis is going to be that the population mean is less than $1,400. And then in the absence of any other information, we are going to assume it's not that. So the opposite of that would be that it's greater than or equal to $1,400. It's important to remember when you're constructing your hypothesis statements that the null hypothesis, the equal sign, so in this case, this is a greater than or equal to, so you have a little bar underneath the greater sign, that your equal sign, whether it's equals or it's greater than or equal to or it's less than or equal to, that equal part of it should always be in the null hypothesis. So now we are going to conduct the hypothesis test for Waverley in Australia for the hypothesized population mean of $1,400. So this is the Airbnb data set for Sydney, Australia. Then what I did is I filtered this data from Sydney, and I'm honing in and I only selected Waverley. Summary statistics in Excel, you want to make sure that you don't run that on the entire Airbnb data set. So Excel is not going to be smart enough to only run it on a subset of your data. So it's really important to if you have like a larger area that you started with for the project and then you picked a different area, you would want to take that filtered data and put it on a different sheet so that on this Excel sheet, you only have that data. So when you're running your analysis, you don't run an issue where it's incorrectly calculating like the sample mean, for example. So you're gonna be on the data sheet that you're working with. So in this case, Waverley listings. You're gonna click on the data ribbon on the top, and you're gonna go to find your data analysis toolpack. And it's going to pop up. And if that was the last thing that you did, like if it's me, then that one will already be selected. So I want to run the descriptive statistics. So I'm going to click OK. It will remember the last thing you did. So make sure you double check this. The other thing that it does work in the descriptive statistics is highlighting the whole column for the numerical variable that you're interested in. So in this case, I'm running my hypothesis test on the weekly price. So I'm just going to select column O. Excel is smart enough to know all of those blanks down on the bottom of the sheet it doesn't care about. Make sure you do the labels in first row. You will get an error if you don't check this little box because we included row 1, which says weekly price, and Excel can't calculate the sample mean on a text field. I always recommend new worksheet. I wouldn't recommend using this output range. You could get error if you don't have room for it. You have to check this summary statistics box here, or you get an error saying it doesn't know what it needs to do. So this is our confidence level. So if I'm doing a 0.05 alpha, that's a 95% confidence level for the mean. You check that, you type that in, and then we will get what we need for our confidence interval. So remember I showed there's like 3 different ways you can calculate the margin of error using 2 functions in Excel, as well as just using this output right here. So I'm going to go ahead and click OK, and I get that output on my new sheet called sheet 4. And then what we're going to do, copy this data, and I'm going to paste it over here so that I can easily reference it. We're not talking about confidence intervals, but I'll just come here real quick just to see what that video, and we calculated our confidence interval for our sample mean. The lower limit was 1233 and the upper limit was 1459. The confidence intervals can actually give us a clue hypothesis outcome is going to be for that hypothesized population mean. We're going to go ahead and complete this sheet right here. I determined that I want to do 0.05. This will always be given to you in the homework problem, in the quiz, and the test. You'll always be given your level of significance, or the alpha, this symbol right here. I brought in my hypothesis statements. So the null hypothesis is that the population mean is greater than or equal to 1400. And the alternative hypothesis is the population mean is less than 1400. First calculation we need to do is our degrees of freedom, which is n minus 1. Summary statistics gives us that, but this is our sample size. So I have 578 Airbnb listings in Waverly that have a weekly price. So my sample kind of contracted a little bit from the bigger data set because I filtered it for 2 things: for Waverly, because I'm only focusing on that area, and I'm hypothesizing about properties that have a weekly price. So I also filtered only to Airbnbs that have a weekly price. So it's going to be 578 minus 1. Now you can see though that this is really big degrees of freedom. And so we know with the big sample size like this, you should think to yourself, okay, this is going to be almost like a Z critical value because the sample size is so big. It's a lower tail test because the alternative hypothesis is pointing to the left. The reason why you know it's definitely not a 2-tailed test is because we're not testing whether something is equal to something. A 2-tailed test for a mean is going to be, is it $1,400 or is it not $1,400? And so if it's the $1,400 would be in the middle for our population mean, and we're basically saying, hey, is it over here or is it over here? So like if we were just trying to determine, hey, we're hypothesizing that it costs $1,400 per week in Waverly, is it that or is it not that? That would be a 2-tailed test. In this particular example, and this is the same thing that I did with the quiz. So like this problem is very similar to the quiz. Is because the reason why I'm doing the lower tail test in these examples is because I'm like thinking from like a person's perspective that I want to make sure that it's not greater than some amount and it's lower than. So if it was actually way cheaper, so if we found Waverly to be a good place to open our business and it ends up being $1,000, that's awesome. That's great for us because it's cheaper, right? So we don't care if it's $1,000 or $1,300. What we care about is it less than $1,400. So that is going to be our lower tail test, and we have here's the same symbol. This little screenshot right here is a screenshot from the bottom of the Chapter 9 practice problem worksheets, just as an FYI. I brought it in here because this also has just things that I could reference when we're doing this. So our hypothesized population mean is actually stated right here. It's $1,400. So we are trying to determine if we can conclude that we're less than $1,400. So that's what we use for our hypothesized population mean. So that this number will always be in your statements, your hypothesis statements. All right, so I don't know the population standard deviation for Airbnb in Sydney. I don't have that information, which is normal, right? That's just kind of the normal way it's going to happen in real life. So since I don't know that information, we know that we have to calculate our T critical value So we're going to type in equals t.inv. Probability is going to be our alpha, and our degrees of freedom is going to be 577. And if I click enter, we get negative 1.65. If I add, I'm going to have one more decimal. So the next piece here is we got to calculate our sampling error. So the sampling error is going to be our sample mean, and that's why I brought in my summary statistics over here so that I could easily reference it. So our sampling error, the mean that comes out of your summary statistics, this is your sample mean. So we're going to say equals sample mean minus population mean. So this is going to be negative, right? Because it's lower. So that's a good sign. So now what we got to do is we got to calculate t-test statistic. So let's find our formula. Here's our formula right here. It's going to be the sampling error. So we just calculated that. Sample mean minus population mean divided by the standard error. Well, what do you know? They gave us the standard error right here, but let's double check Excel. So equals standard deviation. So that number divided by the square root of sample size. And so this is the same number. So all I know now to calculate my t-test statistic, all I got to do is do equals the sampling error divided by the standard error. And I get a t-test statistics of negative 0.93. Here is our graph. I know it's small. I'll zoom in a tad here. So our negative critical value is negative 1.647. Our negative 0.93 would be somewhere like right here, right? It's going to be in this area. If it was less than negative 1.647, it would be a lower negative number, right? And so since it's in this white area here, it's not less than the critical value, we would do not reject. So our decision for this particular data set is that we cannot conclude from this sample that the population mean is less than 1,400. So this is in the do not reject region.